Good evening, everyone. On behalf of agricultureinformation.com, I welcome Mr. Tarun Jami, and he will talk about transforming stubbles into sustainable strength, bioconcrete innovation using agri-waste. I now request the speaker to begin. Thank you.
Thank you so much. It's a pleasure. Thank you so much for having me here today, and giving me the opportunity to speak about our work. My name is Tarun. I'm the founder and CEO of GreenJams. At GreenJams, we have a singular goal. We want to remove 10% of global CO2 emissions, and we make that happening by fixing the materials with which we make our buildings. We all know that construction and the built environment, buildings essentially are the largest contributors to climate change. Almost 40% of the world's CO2 emissions come from buildings alone. And there's a dual problem. The second challenge also that we're trying to overcome is the large crop residue burning problem in India. Approximately 100 million tons of crop residues are burnt annually, causing almost 2 lakh crore rupees in economic losses to the country because of loss of public health, poor worker productivity, and so on. So fundamentally, the question that we're trying to answer at GreenJams is, what if buildings could help reverse climate change without burning a hole in the pocket? And the answer to that is agrocrete. It's the world's first verified carbon negative bioconcrete, which is made using crop residues like rice straw, wheat straw, bagasse, cotton stalks, corn stalks, and so on, and byproducts from the steel, power, construction, mining, ceramics, and a few other industries. We don't use any cement, and our innovation lies in converting conventional, majorly available crop residues into strong carbon negative concrete products. Agrocrete is patented in India, UK, South Africa, Thailand, and a few other international countries across the world. And the product has been tested and certified by the Central Building Research Institute in Roorkee, ratified by BMTPC, and our claim of carbon negative is third-party verified and validated on the international EPD system. So at this current point, we're actually trying to build an ecosystem of carbon capture using agrocrete, and um, the fundamental raw material that we use to make agrocrete happen is the crop residues. We started with the bricks and blocks. We're soon getting into 3D printing, precast, ready-mix concrete, and so on. So what we're essentially trying to scale up at this point are the bricks and blocks business. And to essentially sum up all the numbers that you see on the screen, what I'm trying to say is agrocrete is stronger than conventional bricks, has a long life, has very little water absorption, which means that you don't see any dampness in the walls. And the U value, which is the thermal insulation of the material, is almost is best in class. And the embodied carbon is in the negative values, which means that by leveraging the carbon that has been captured by the crop residues, we're able to sequester more carbon in agrocrete than we're emitting during the entire manufacturing process, which makes it carbon negative. So what we're essentially helping our customers achieve is up to 50% reduction in wall making cost and a 3.5 times higher thermal insulation, all while giving them an opportunity to make buildings carbon negative. So this is how our theory of change works. For every 300,000 square feet or 3 lakh square feet of construction, we're able to sequester almost 1,000 metric tons of CO2 and prevent an additional 3,500 metric tons of CO2 emissions by replacing conventional materials. On top of that, our customers save costs, significant amount of costs, while also being able to prevent over 1,200 metric tons of crop residues or stubble from being burnt. So far, this is the sort of impact that we've been able to achieve. We basically have 3 manufacturing units. We've completed 16 projects, and we have a 90% customer retention rate. Some of our marquee customers include ITC, and we're currently trying to fulfill a deal pipeline worth almost 160 crores. So these are some highlights of some of the few projects that we've completed in the past. On the top left corner, you would see a building which is built in Vizag, where we have been able to demonstrate 60% reduction in energy consumption, On the bottom right corner, you would see another house built in Vizag where there is no air conditioning needed. I would like to repeat, in Vizag, where there's no air conditioning needed, this is a hot and humid region. Every house in Visakhapatnam tends to install air conditioning because of how hot it gets. And similarly, we've built projects across the country. We have one project in the in the Himalayas. There's one in Goa. There's one more in the southern part of India, including Rajahmundry, Chennai, and so on. So how we plan to scale up is through partnerships. And I think that would be a point of interest here with this particular audience, which is that we're trying to build a decentralized hub and spoke operations model where we partner with individuals to set up manufacturing units in locations that we have identified. And it's the partner who essentially helps procure the crop residues. We, of course, support in making the relevant connections, but then we find local entrepreneurs who will go about doing aggregation and collection of crop residues from farmlands in their particular region. And then we also help in procuring the filler materials. These include byproducts like construction demolition waste, soil excavated from construction sites, and so on. And most importantly, there are in a concrete, the most important raw material is always the cement. And in the case of conventional cement, crop residues are not compatible, which means that we had to go out there and invent our own alternative to cement. We call this binder, and binder is something that we manufacture in-house. We take care, um, we support the partner in doing the manufacturing operations through our own teams who go to the manufacturing units, support in doing the upskilling and training of the workers there, produce the products according to our SOPs and internal standards, and we take care of the market access. So we do the sales and marketing, we do the market development and ensure that the product being manufactured by the partner is being taken by the customers. So we are a pretty well-rounded team. I am Tarun. I am the founder and CEO. I also invented the product. I come from 10 years of deep tech experience in the space of bioconcretes. I have a PhD in civil engineering. And then there is Mr. Jalen Murthy, who serves the company as its managing director. He's also an industry veteran with more than 37 years of experience, has built over $1 billion worth of construction, and was supported by a robust head of growth and a product stewardship lead who also come from within the industry. So I'm also happy to report that we've been supported immensely by the government of India through various grants and non-grant initiatives. We've also been recognized by several non-governmental institutes and international organizations from across the world who have supported us as we scaled up this company. So I am more than accessible in the below the mentioned contact information, and very happy to get in touch to share more information about how we could um, support each other.
Thank you very much, sir, for your talk. I will take up the questions now. In the meantime, can you please stop sharing the screen, sir, so that we can see your full video?
Yep.
Yeah,
Yep.
thank you. I'll move on to the questions, sir. What specific types of agriculture waste, like stubbles, or straws, are most suitable for use in bioconcrete, sir?
So we've developed a technology where most major crop residues can be used in their raw form to make agrocrete. So, uh, we have developed mixes using paddy straw, wheat straw, bagasse, cotton stalks, corn stalks, cane trash, um, and several others. So for other types of agricultural waste which are not stalks or which are not a straw type of waste, we are also able to convert them into a form called biochar that is then useful for making concrete products.
Okay. Are there any key challenges in scaling up the production of bioconcrete using stubbles and agri-waste, sir?
Yeah, so there are definitely quite a few challenges. One key challenge that we're trying to overcome is the lack of awareness. We don't have the same level of recognition and adoption from, say, for example, even government bodies, where this is being widely promoted or accepted. Second, of course, is the manufacturing challenge at this point because this is a relatively newer product. It would involve a significant amount of effort, not from just us, but from the wider community also to um, uh, to accelerate adoption and also develop a market that would help us in increasing or ramping up our manufacturing capacity.
Okay. Are there any real world example or pilot project where this bioconcrete has been used in construction?
Yes, I've just shown you a few examples. We've completed 16 projects across the country in 7 states of India. Some are industrial, some are residential, some are commercial. Um, in fact, there's also one hotel that has used agrocrete.
Okay. What is the cost difference between producing bioconcrete and traditional concrete? And is it viable for large scale use?
Yes, so we are rapidly reaching a point where the cost of manufacturing bioconcrete is very, very similar to the cost of manufacturing conventional cement concrete materials. The key challenge here is because cement is such a widely used material. The scale at which cement is manufactured, and when the economics of scale kick in, cement does turn out to be significantly less expensive as compared to binder. But because binder is right now manufactured in small batches, it turns out to be a little bit more expensive. But as we expand in scale and as we are able to produce more of this, uh, we would also be able to match the costing of manufacturing bioconcrete.
Okay. How can government policies support the integration of agri-waste into the construction industries?
So government does play a very important role in adoption of new technologies, but more than the government, it's also down to the individuals, right? I mean, um, yeah, as just consumers of these sort of materials, we definitely need wider amount of recognition and wider adoption so that the government can develop policies around these new types of materials. But having said that, there are definitely initiatives by the government of India through which we can, get wider adoption and recognition. In fact, we are working with a few local governments in Andhra Pradesh to, scale up the adoption of agrocrete.
Okay. What kind of incentives or subsidies could encourage farmers to supply stubbles instead of burning it?
Well, I don't think any amount of subsidy or incentive, at least from a government, I would categorize these as freebies. I don't think any amount of freebies is going to incentivize anyone to prevent burning of crop residues. What I definitely think would help is when you're able to create value for it. Like, for example, we procure crop residues at almost 6,000 rupees per metric ton from farmers, which is um, the highest that anyone could get for stubble that generally gets burnt.
Okay. Sir, what inspired you to explore the use of agriculture stubbles and waste in concrete production?
So it's a personal story, really. When I moved to Roorkee to do my PhD, um, I had to pass through Delhi during the winter months, and um, I personally suffered from the poor air quality that happens in that particular region due to the stubble burning and vehicular pollution and so on. And that's when I realized that this was a significantly large problem. Um, I mean, millions of people breathe the smoke that comes from open air, open field stubble burning, in fact, for almost a quarter of a year for their entire lives. And I thought that was not a good way for anyone to lead life, and which is why I decided to come up with a solution that could be scalable using the education that I had.
Okay. What challenges did you face while developing a material that balances structural strength with sustainability?
Well, I come from this industry. I spent almost a decade in bioconcretes. So from an R&D perspective, it wasn't very, very challenging. The key problems that that this technology had were that there did not exist a binder, right? A cement that could be compatible with crop residues, with biomass. So that was the only challenge that had to be solved, and that's what I went about solving. And after that, the technology by itself started becoming technologically more viable and also commercially viable.
Okay. What tested and certification process did your bio-based building material go through to ensure structural safety and compliance?
Yeah, so it was there as part of my slides where there are, so I mean, fortunately, because this industry has lasted for several centuries, there have been multiple standards that have been developed by bodies across the world, right? These include our own Bureau of Indian Standards, then you have ASTM, and then you have Australian, New Zealand standards, you have British standards and European standards and so on. So, as part of the R&D process, as part of the product development process, we put Agrocrete through all of these tests that are mentioned in these standards. And only after the product had met or in fact exceeded a lot of the requirements set in these standards did we then decide that this could be a good material to be that we can start building with. So first and foremost was definitely doing thorough, rigorous, scientifically rigorous R&D before launching it in the market.
Okay. Have you created any formal partnership with farmer producer organizations or rural cooperatives for stubble collection?
No, so we don't have any formal partnerships with any FPOs or cooperative societies. And that's also because the scale at which we're operating is significantly small. But as we scale up and we become larger, we definitely plan to execute some sort of partnerships with FPOs.
Okay. What advice would you give to young entrepreneurs looking to work at the intersection of climate tech, agri-waste, and infrastructures?
That's a difficult one. See, I think entrepreneurship is a deeply personal journey, and uh, you know, the people. So at the end of the day, entrepreneurship simply means that you're able to solve a large problem that a large section of the population is facing, and you're able to do it in a manner where they don't feel that pain anymore, and which is why you have the right to win, and that is why you have the right to make any sort of money. So my advice would be to ensure that be customer centric, keep speaking to your customers, understand what their pain points are, and ensure that the problem that you're solving is being felt by a large section of the population. Only then will you be able to find any success. And at the core of it all, start young so that you have the ability to make mistakes. And even if you fail, you will be able to use those failures to build a robust portfolio that can accelerate your career.
Thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Mr. Tarun Jami for the talk and for answering the question. This meeting will now be closed.
No problem at all. I think it was great. Thank you so much for having me here.
You're welcome, sir. Bye-bye.